This video is brought to you by Crankshaft&Co LLC, Performance and Repair. In this video, we will show how to re-sleeve a damaged cylinder without complete disassembly of the power head. This cylinder clearly has a problem. The damage is extensive to say the least. The good news is that the crankcase cavity is undamaged, and so is the connecting rod journal. Our video will pick up here after having removed the damaged sleeve. We will then have to do some prep work and fabricate some specialized tooling that will be necessary to do the job. Since we won't be able to bore the new sleeve once it is installed, some pre-boring will be done, as shown here. Now onto the video. Thanks for watching.
Okay, so with the low hone we have got the cylinder bored and rough honed just about to the standard diameter. It's a little tight because I'm going to leave a couple thousandths on for final honing in the block. So the piston's just starting to go, and I don't want to take any chances on any final roundness once it's pressed in. I want to leave a couple thousandths on there to clean up. Okay, but that's pretty good now. I'm going to stop there. But an important step that you want to do is, so these ports will all have very sharp edges on them, and you always want to chamfer your ports a little bit, about 40 thousandths. If you've ever snagged a ring on a brand new cylinder, you'll never not chamfer your ports. So we're going to use just a little ball hone or ball die grinder here, and we'll go around the tops and the bottoms of all the ports. Alright, so basically I'm going to put this in the freezer, cool it down, and we will then go back to the block and put her in. Alright, so an important part is pre-aligning the sleeve to the cylinder to get the ports aligned correctly. And what we'll do is pre-mark the sleeve based on the port geometry internally. And if you can see that, I've gone in and made some lines so that those ports will line up properly. This little this is like a to open the it opens the exhaust port early, but that has a good mark inside the cylinder that we can align to. And even on a factory block, you're going to find that these sleeves aren't always perfectly aligned, but you only get one shot at it, so that's that. We're next going to put the sleeve in the freezer and give it a couple hours, and then we'll heat the aluminum jug here block to give us more thermal expansion to open up the clearance a bit and help us relieve the amount of pressure required for this press. So we'll go ahead and put the sleeve in the freezer, and then we'll install the press tool. Okay, so back at the block we're going to install our press fixture. This is the the base frame right here. Then we'll install the press plate tool. Okay, now we're ready for the sleeve. First we will heat up the block a little bit.
Does it look okay?
Yeah. Okay, give me some cranking. Hold on. Okay, go ahead and crank. Put the wrench on.
There's not even much resistance.
Not much resistance?
No.
Okay, get the air ratchet. Put that on it while we got it going. So we are really tight. There's a lot of torque on there, and I believe it's seated, at least to the accuracy of the depth of the sleeve, because we're flush with the press plate. Press plate has a step on it, so it's designed to go flush with the block as long as the sleeve will go all the way to the bottom. Probably a little better. All right, so it is standing proud a little bit, probably like 10-12 thousandths, which is probably designed to do. We might have to surface the block, but better that it's sticking up a bit than recessed, because we need the head O-rings to seal tight against this. So that is a preferred condition, and what we're going to do is, they say you should always leave the pressure on it while it comes to temperature. Alright, so like I was saying, the sleeve is standing proud of the cylinder, the aluminum, by about 15 thousandths. I've measured this with a depth mic, and that's about what it is. And I want to use a grinding wheel, I'll show you that, to slowly just take that off without removing any of the aluminum, because the head has to sit flush with both the sleeve and the aluminum. So I'm going to use some layout compound here, a layout die, and this way I will know if I get the two surfaces flush, and I really don't want to take any off the aluminum. There is an O-ring that seals this, but these O-rings are really pretty small, so there's not a lot of room for error. So what I'm going to do here is I'm going to use a grinding wheel with my plug as a like a mandrel to guide the wheel and keep it centered, and just slowly take material off of the sleeve, which is iron. That'll grind fine, and I want to just stop when I get it flush. So it's working. You can see I've started taking material off the sleeve, and we're going to stop when we see some of this dye rubbing off of the aluminum, so we'll know we're flush. And like I said, we want to maybe finish this just with a sanding pad, because I really don't want to take any off the aluminum. Well, it's coming off. It's coming off slowly, which I figured that. But we'll just keep doing it till we get it to where we want to be. All right, so I think I've just about got it. Just hit a little bit of the aluminum right in here, so I'm going to stop, and I think I'll get a sanding pad and go over the whole thing and try to blend it all in. Alright, so this is after using a orbital sander to just lightly surface everything all over and take off any of the old corrosion, etc., that is sort of built up everywhere. That looks pretty good, and I will check it. Really what we want is a good evenness. With the other cylinders, and that's looking good. This is not a head gasket, it's O-rings, so there is a little bit of more tolerance here. If I saw some major warping, that would be a different story. We would have to set this up to deck it off with the mill. But I think we're going to be good, and we're going to do a pressure test to make sure that there's no coolant leaking by that O-ring. Alright, so I've cleaned up the sleeve clear to the bottom with a smaller hone, and I'm getting really good measurements with the bore gauge. And I'm right where I want to be for the piston clearance, and we'll try it here. Alright, we're clear to the bottom, and I think I'm going to do a little more honing at the bottom here. I might even chamfer, might enlarge the chamfer on the bottom of the piston, because I can't quite reach 100% to the bottom corner there. So I think that might be a good idea. Alright, so I've cleaned up the bottom a little more and enlarged these chamfers a bit. measured everything. We're good on the measurements. So this is going nice, smooth, clear to the bottom. Got some got clearance at the bottom now. So. Alright, so with that I think we're in good shape. Really now we're just going to do a little bit more with the spring hone just to get some good cross hatches in it and put it all together. We'll run it and compression test it. Okay folks, so moment of truth, here we go. I've got the battery rigged up, ignition on, and I've got fuel to it, and we are gonna give her a go. That's more like it.